Hello, my name is Alexander Kim, and welcome to Neural Networks. What are neural networks? Neural networks describe an artificial intelligence technique that makes models more complex and intelligent. These are made to imitate the brain's neurons and have multiple layers consisting of connected neurons. Each connection has weights and biases, and the input is multiplied by their respective weight and summed with biases in order to get the output. Here's a visual. You can see that there are two hidden layers which perform calculations. And you see the input and the output. This curve represents an activation function, which we'll go over later. And here's the actual code. The model is trained to recognize 28 by 28 pixel images and classifies them into one of these 10 classes. There are 60,000 training images and 10,000 testing images. The epochs listed in the training section represent the amount of times the model will go over the data. And this bottom part prints the first 5 images and their prediction based on the trained model. Please note that this code is not original and comes from the TensorFlow official website and TensorFlow 2.0 crash course. Parts of a neural network. The first part, we have layers and neurons. You can see that we have an input, hidden, and an output layer. The hidden layer has 128 neurons, and the output layer has 10 neurons for the 10 classes. The activation functions, as you can see here, are used to add complexity to the model. When the weighted inputs and biases are added, it will result in a linear model. But we want the model to look more something like this. This is the rectified linear unit used here. Even something like this adds a little bit of complexity to the model and allows the output to be in a limited range of 0 to positive infinity, opposed to all real numbers. These are 4 of the common loss functions that are used today. The loss functions tells the model which way to go to minimize loss, or the difference between the model's output and the true output. Optimizers work with the loss function in order to reach the global minimum of loss in order to improve accuracy. Let's take a look at the results. These are the results with 20 epochs. More epochs aren't always better, because the model may be able to memorize certain images and develop patterns specific to only those images. You can see that the first epoch had 82% accuracy, and the last epoch had 93% accuracy. But you can see that the tested accuracy was 88.7%. As stated before, the model may be able to somewhat memorize the training images, get a better accuracy in the training. The first 5 images were all correct. These are the results with linear activation. Recall that linear activation limits the complexity of the model, and the output activation must be kept as softmax in this case, because changing the output activation would change the model's interpretation of the output and bring the accuracy to around 10%. You can see that the last epoch dropped 7% accuracy, and the tested accuracy dropped 5%. Still got the first 5 correct. Here is an alternative code from the TensorFlow website, which produces similar results, with only slight modifications in the model. And here are 2 pages of works cited. Thank you for your time, and please feel free to ask any questions.